When the x-intercepts are given to you, the best way to start the problem is starting off with the intercept form. Okay. We did this yesterday, so can someone tell me what is the x-intercept form of a function? Y is equal to?
A times x minus p, x times x minus q.
Correct. Very good. And what is p in this problem?
0.
Correct. And q is?
10.
And we are going to substitute those into the equation. You still know that the a is kind of missing, which is okay. X minus 0 and x minus 10, which is a times x minus 10. How do you find a? A is a missing variable there. We don't want to see a there. So what do you do to get the a?
You use the other point they gave you and plug it in.
Very good. What is that extra point actually?
9 comma negative 27.
9 comma negative 27. Okay. So substitute 9 comma negative 27 into the above equation. You guys do that? Okay, so
A equals 3.
Okay, are you all done with a is equal to 3? This is negative 27. 8 times 9 minus 10, correct?
Yeah.
Which is 9 minus 10 is negative 9. So this is, sorry, negative 1. So this is negative 9a is equal to negative 27. So a is equal to negative 27 divided by negative 9. Yes, that's correct. A is equal to 3. Now that we got the a as now we got the a also, you can write the equation. So therefore, equation is y is equal to 3 parentheses x parentheses x minus 10. You got everything you want to write the equation, but do you guys think you are done with the problem?
No.
What else do we need to do?
Expand it.
Expand it, because we are looking for the standard form. For the standard form, you need to expand all these. So 3x times x is 3x squared. 3x minus 10 is minus 30x squared. I'm sorry, 30x. So that's the equation in the standard form. 3x squared minus 30x. Are we good?
Yeah.
Okay. So remember the x-intercept form. You wrote the x-intercept form. You use the x-intercepts p and q for p and q. The only missing variable was the a, and that is why we need the extra third point. You're substituting the x and y into this equation and found what a is, which is 3. Once you get the third variable a, also put it back into the equation. And then you just have to do one more step because you're asked to find the equation in the standard form. So just nothing other than just expanding, that's it. And you got the equation. Good?
Yeah.
Okay, so now I'm thinking maybe we can skip. What do you guys think about 13?
What?
Number 13. Why it's only 2 points given to you? No, that's kind of, because when you only have 2 points given to you, like you see that one of them is the x-intercept, the 4, 0, right? But the other 9 is just a point, and you know that that's not enough to start the intercept, right? So 13 is kind of an ambiguous case because you can think of this as the vertex if you want, or just an extra point or however. So I'm just going to skip 13 for now. It's not clear, the question. But I would like to do 14. So let's try 14. Number 14. Okay, so what it says is that you have a table of, you have a data table. You have to tell whether the data can be modeled by a linear, exponential, or a quadratic function. And then you have to write the function that models the data. We have done several of this in the past, like a couple of weeks. Let's try one more, which is 14. And the table is actually the distance from Earth, distance that Earth moves in its orbit around the sun. Okay, it's between Earth and sun, it's a distance. Okay, so when you have a data table, how do you figure out what kind of function it can be modeled by? Anyone? How do you know?
You find the first difference?
Correct. You're going to find the first difference first. Let's check this. What is this difference?
19.
Okay, that's correct. First difference is 19. How about these two? 57 minus 38.
19 also.
Okay, how about this? 76 minus 57.
19.
Are you checking, Joel, or are you just saying?
Well, I mean, it makes sense.
Okay, 95 minus 76 is?
19.
19. So you actually got lucky here because the first difference itself is a constant. Okay, when the first difference is a constant, how do you model the data?
A linear function.
Linear. It's going to be a linear function.
Wait, Mr. Hondas?
Yes.
Sorry, I came late. What page is this?
This is the chapter test from chapter 8.
Okay.
I don't know the page. I think you can easily find out, right? Just
Yeah.
go to the right, yeah. So this is going to be a linear function. So what is the standard form we normally use for linear function? And what is this 19 actually?
The distance.
The slope.
The slope, right? This is the constant rate of change. So you got the 19. The first difference, the constant rate of change, is the slope, which is m. So we got the m as 19. Now, how do you come up with the equation?
Y equals mx plus b.
Correct. Let's say the equation is y is equal to mx plus b. So y is equal to 19x plus b. Can we box this as the answer? No, you need to find b now. B is a question mark. How do you find the b?
You go You put the t as 0 and then subtract 19 because 19 is the slope.
Correct. So what you can do is, you know that B is the y-intercept. Y-intercept happens when x is equal to 0. So if you just go back one more time, you actually get the y-intercept. Is that correct?
Yeah.
So just go back one more time. That means go back. Oops, okay, I don't know what I'm doing. Okay, go back one more time. When you go back to 0, what is the y value?
0.
0. So you have y. What am I doing? Okay. Okay, I don't know. Okay, y is equal to 19x plus 0, or y is equal to simply 19x. Is that clear? Okay, so we got y is equal to 19x because to find the y-intercept, we just needed to go one back. Or you can pick any of this point and substitute for x and y and find the b. You can do that too.
Mm-hmm.
Okay, are we good? Okay, I think I'm going to conclude chapter 8 with this. These are the things that you need to know. Again, I know that I said this many times, but that chapter was very, very important for you guys, okay? So make sure that you know that very well. Okay, I'm going to move on to chapter 9. So let's see. 9.1. Okay, write the title, 9.1. Maybe take a new binder paper, 9.1. Sorry. Okay, properties of radicals. You guys read and write down if you need things. Right up to here. Okay, so tell me, what are these radicals?
An expression that contains a radical.
What is radical? What is that radical means?
A root.
Correct. This symbol is the radical. It could be cube root, it could be fourth root. So basically this symbol, all these roots are called radicals, okay? Okay, and this number right here, for example, when you do cube root, this number is called the index, right? And let's say if this is x, the thing that's inside the radical is called a radicand. So the number that sits in the basket looking thing is the index. Whatever that's inside the radical is radicand. That root symbol itself is called the radical. So radical, index, radicand. To get it. All right. Okay, now. Okay, the next thing is, how do you know if a radical expression is simplified? How can you tell if it is simplified? So the 3 bullet points are the things that you're going to check to see if your radical is simplified or not. Okay, for that, before that, let's see, let's see what are those, like how do you know if something is simplified? You cannot have any perfect squares sitting inside the radical. That's number 1. Other than 1, there should not be any perfect squares or perfect powers sitting in the radicand. You cannot have radical in the expression, in the denominator. You cannot have fractions as radicand. You cannot have this, you need to split like this. Right? No radicand contains fractions. For example, you can do this. That's not okay. You cannot have a radical in the denominator. So if you can take care of these 3 things, or mainly 2 things, right? This and this, maybe we can put them together, these 2 together. So basically how do you check if a radical is simplified or not? Number 1, you cannot have perfect factors sitting inside the radical. You cannot have radical in the denominator. You cannot say 1 over radical 2. You cannot say 3 over radical 2. You cannot have square root in the denominator. Clear? Okay, let's take a look at these 2 properties. If you are taking the square root of a product, a times b, you can actually split the square root and take the square root of each of the factors. You can take the square root of a and multiply that by the square root of b. And if you're taking the square root of a over b, you can do the same thing. You take the square root of the numerator and divide that by the square root of the denominator. So square root of a divided by square root of b. Provided your b cannot be 0. Okay? And also these conditions, because you can never take the square root of a negative number. That is why it is always says that greater than or equal to 0. It can take 0, but it has to be greater than 0, because we never take the square root of negative numbers. That is why these conditions are here. And for b, it cannot even be 0 because division by 0 is undefined. That is why b cannot be 0. Over here, b can be 0 because there is no denominator here. But here, b cannot be 0. All right. So that's all the little talk before we actually start doing all the examples. Now, do you all get what a radical is?
Yeah.
Say yes or no. Okay. Do you know what an index means?
Mm-hmm. Yes.
A radicand.
Yeah.
Okay. Do you know that you cannot have square roots or radicals in the denominator?
Yeah.
Okay. All right. Let's do the first example. How do you simplify? So we are going to make sure that we do these 3 bullet points. We take care of these things when you do simplification. That's what it means. Okay. First one, square root of 147. Does the answer come to your head?
No.
Immediately. It's not, because 147 is not a small number. You can do, you don't know if there is a perfect square sitting inside that 147. So what I'm going to do is, like, I'm going to teach you guys a different method. I don't know if the book is using this, but this is a method that worked for my students long time ago. Okay, let's see. I'm going to show this. What I want you guys to do is the prime factorization of 147. Okay, prime factorization of 147. And this is what I'm going to do. I don't know, however you want to do the prime factorization, go ahead, but I want to see prime factorization first. I'm going to do the factor tree. When you do the prime factorization for 147, can you start from 2?
No.
No, because 147 is not divisible by 2. So what is the next small number?
49 times 3.
Okay, so 3. How many times does 3 go in 147?
49.
49. Now we have to split the 49. And I think that you guys know it's 7 times 7.
Mm-hmm.
Because remember, before the break, we memorized all those perfect squares. I wrote it on the board.
Mm-hmm.
You guys missed class?
Kind of.
Kind of, okay. Okay, so prime factorization of 147 is actually 3 times 7 times 7. Are you guys with me?
Yes.
Okay, so square root of 147 is actually square root of 3 times 7 times 7. Correct?
Mm-hmm.
Okay. Now this is the main thing. Every time you have a factor pair, which is 7 times 7 is 49, right? What is square root of 49?
7.
Yeah. Okay. You don't have to do this step that I wrote now. You don't need to do this. But I'm just telling you, every time you have a factor pair, that one of them goes out of the square root, because that is always going to be a perfect square. Correct?
Yeah.
So this is going to be square root of 7 times 7. Every time you have a pair, just one of them goes out of the radical and everything else remains inside that. Because square root of 7 times 7 is 49 and square root of 49 is 7. That is why that 7 is now outside the radical. That's how you know that you simplified completely. Okay?
Wait, how do you know if the 3 is the radicand?
Yeah, because the entire 147 is under the radical, correct?
Yeah.
So that means the entire 3 times 7 times 7 is under the radical. And then I'm going to use this property right here. See, when you have so many things multiplied together inside the radical, you can start taking them, you can split them.
Oh, okay.
And then since the 7 and 7 is a perfect square, when you split them, it's square root of 49, which is 7. That 7 is not inside the radical. That is outside, because it's actually square root of 49. That is why the 7 is now outside. Since the 3 is only one of them, if the 3 had one more 3, then that would also go out. So every time you have a factor pair, one of them goes out.
Oh.
And that actually vanishes. The factor pair vanishes. The way it vanishes is like one of them goes out of the radical.
Oh, okay, I get it.
Okay. Okay. Since I don't have enough space here, I'm going to maybe, what is the next question? Square root of 25x to the power 5. Okay, you guys also don't have the question. Okay. What do I do? Did I not get that? How do I get paper? Can I just take this one? So when I add things, it's just camera, all those things, but I can do paper. Oh, no idea. Okay, yeah. All right, guys. 25x to the power 5. 25x to the power 5. No, that's not what it is. Okay. Okay, then I think I only just showed this. Okay, so 25 x to the 5th power, everything under the square root. So you're going to split that 25. The reason I'm not going to do the prime factorization for 25, because you know that 25 square root of 25 is 5, right? It's not a big number for you to split it.
Yeah.
And then x to the power 5.
Oh,
Square root of 25 is 5, you know that. So you don't need the factor tree or anything for 25 because it's small enough for you to know what it is. And x to the power 5, I'm going to split that into this. Now, do you see that the 5 is without the radical? Why? Because square root of 25 is 5. Don't put the square root for 5 also. Correct?
Yeah.
Okay. Now, as I told you guys earlier, okay, no. For every pair, every pair vanishes, but then when that vanishes, you get one of them outside. Because this is going to be x squared. What is square root of x squared?
X.
X.
And we have one more factor pair. So one goes out from each factor pair. So one from here went outside, one from here went outside, and the remaining, there is only one, and that stays inside because we don't have another pair to kick them out of the square root.
Oh.
So this is 5x squared, and the one that's sitting alone without a pair stays inside the radical. So this is the answer for that. Okay, I want you guys to take a little bit more time to see if you really understood this. And ask questions if we have.
Miss Mohandas,
Mm-hmm.
for the chapter 8 test page, were we supposed to do all the problems? Like from 1 through 17?
Joel, did you miss my other classes?
Yeah, I missed your other class.
That's why. We did all.
Oh, you did all of them? Okay.
Why did you not come?
I forgot because like I was still in spring break mode.
No. I actually started the review before the spring break. So did you miss only Mondays? Joel?
I didn't come because I thought that I just assumed there is no classes during spring break.
No, we didn't have spring break. We did not have class in spring break. I'm talking about the week before that.
Oh yeah, those ones I came to. I'm just saying during like the one where you did this chapter 8 thing.
Okay. Yeah, no problem. So we did yesterday.
Okay.
Not yesterday, Monday.
Okay.
So the classes are Monday, Wednesday, Friday, okay?
Okay.
All right. So the next example, guys, this is B. C is radical 11 over 36. Okay. And we are going to use this rule. When you have a fraction inside the square root, according to bullet point number 2, you can't do that. You need to split them. Okay, so we are going to do the splitting now. It's going to be square root of 11 divided by square root of 36. Square root of 11. Is there any prime factorization for 11? Is there any perfect square within 11, guys?
No.
No.
So that means you can't do anything that's already simplified. If you can't do prime factorization, if you can't find factor pairs, then that's already simplified. How about the denominator? 6. So that's the answer.
Oh, it's just that.
That's it, yeah. Okay, let's do question D. That is also a fraction. So we are going to split the fraction. Okay, what is the square root of 144?
12.
12. What is the square root of n squared?
N.
N. So that's the answer. Okay, question E. Question E, I'm going to erase the work. Okay. Question E is, do you see what is the index in E?
3.
3. That means you're finding the cube root. When you find the cube root, you're looking for not factor pairs, triplets, because when you find a square root, you're looking for factor pairs like this. But when you are finding cube root, you're going to look for factor triples. Okay, I'm going to do the prime factorization for 135 because it doesn't come to my head immediately. What is the lowest factor that you can think of?
5.
Okay, if it is 5, then it's going to be, what's the other factor? 5 and? How many times does 5 go in 135?
27.
27. And now we are going to split the 27. 27 looks like 3 is the smallest one. So that's the factor tree for 135. And now you're going to actually write the question. So cube root of 5 times 3 times 3 times 3. Isn't that 135? Because you take 5, you take 3, you take 3 and 3. And all of them together is 135. Since we are looking for the cube root, are we looking for factor pairs or factor triples?
Triples.
Triples.
So here we go. We have a triple. And when you take the cube root, what do you do with all these triples? How many of them actually go out?
1.
1. Because 3 times 3 times 3 is 27, and cube root of 27 is 3. So one of the 3 from the triples go out of the cube root, and the only thing that's left is the 5, and that's going to stay inside the cube root. So this is 3 times cube root of 5. So, got it?
Yeah.
So you don't put the 3 in the index, right?
No, the 3 is still there. See, this 3 is still here, Jasmine. That's this 3, which is this 3 right there. Just to show that it's cube root, okay?
So you don't have to put it. The 3.
Put where?
The 3 in the index.
No, you have to. I put the 3 there, see? No, this 3 is outside.
Oh, yeah.
Because
Okay.
we have triple. Every time we have triples, one of them goes out and the rest vanish.
Okay.
Okay?
Yeah.
And the only thing that's remaining inside the radical is the 5.
Mm-hmm.
Okay, next problem. It's cube root of 8. We are going to use the property and split them. Do we have to do the factor tree for 8?
No.
No. What is cube root of 8?
0.
2. And cube root of x cubed, watch what I'm going to do. X times x times x times x. Do you guys agree?
Mm-hmm.
Okay. And since it's a cube root, we are going to look for triples. How many triples we have?
3. Or, well, 1.
Just 1. So how many x's will go out?
1.
1. So x goes out of the radical. And now inside the radical, how many x's we have?
1.
1. That's the final answer. 2x cube root of x. Okay, next is G. This is a fraction, so we have to split the fraction. Cube root of the numerator, which is n squared. Cube root of the denominator, which is negative 1000.
You can't. Oh wait, never mind. I forgot that this is cubes, not squares.
Yeah. Cube root of n squared. When you split the n squared, that's only n times n. We don't even have a triple to come out. Do you see that?
Yeah.
So, which means you can't do anything with one. That stays the same. Because we don't have a triple here. But the denominator, do you know the cube root of negative 1000?
10.
Negative 10. Correct, negative 10. Do you notice that you couldn't do anything to the numerator because it's less than a triple? Okay, now H, we are going to split We're going to split the numerator and the denominator. Split the numerator and the denominator. The numerator is actually a product. It's a product of 343 and a to the power 8. So you are going to split them again using the product rule. What's cube root of b cube?
B.
B. The cube, the square root is gone now because this is already a triple and nothing else left. So that just kicks out of the cube root and the cube root just gone. There is nothing left in the cube root. Okay. Now I want you guys to do the prime factorization for 343. Prime factorization of. Okay. Where do we start? Is it divisible by 3?
Yes. No.
Is it divisible by 5?
No.
Is it divisible by 7?
Yeah.
Okay, so 7 times what is 343?
49.
49. So we are going to split that 49 into 7 and 7. So these are the 3 numbers. So then this is going to be cube root of 7 times 7 times 7. Okay, now what about cube root of a to the power 8? So it's going to be how many a's? Okay. Now you're going to look at the triples. There is one triple. There is another triple. And then we don't have enough for triples. Does it all make sense to you guys? Okay. Now what is cube root of 7 times 7 times 7? Hello? Cube root of 7 times 7 times 7 is?
7.
Just a 7 because we just have one triple. And when you take the cube root of triple, you just get that number. Okay. There is, then we have how many triples for A?
2.
2. So that's A squared. 2 of the A's, one A from here, one A from this triple, another A from this triple, but they're all multiplied together. So A times A is A squared. And then what is left in the cube root now?
A times A and B.
Okay.
Yeah, no, B is in the denominator. A times A, which is A squared, and the B without the radical in the denominator. So the final answer is this. Okay. You think you guys will be able to do this on your own?
Yeah.
Okay. So look at this example again and again. If you are getting stuck with any of the homework problems, which I haven't put it yet there, so I'm going to do that sometime today for the homework that's you need to do today. Okay. So one more time, I'm just going to go over the last problem one more time. 343 is actually a perfect cube. It is 7 cubed, so that's 7. A to the power 8. Now listen, once you understand this, like you don't have to write like this all the time. You can skip this step. But instead, can you guys, the only reason I wrote it here, this expanded version, so that you understand what I'm trying to do. But you can think about this, A to the power 8, right? So A to the power 8, and it's a cube root. I don't know if you guys remember, this cube root is actually fractional exponent. Isn't cube root same as the power of 1/3?
Yeah.
Do you remember that, everyone?
Yes.
Okay, so now you do 8. Now what do you do with this 8 and 1/3? You multiply them, correct? The power rule.
Uh-huh.
Okay, so 8 times 1/3 is 8/3. How many times does 3 go into 8? Completely.
Twice.
2 times, and what is the leftover?
A squared.
Which is 2, right?
Yeah.
So this 8/3 is actually 2 plus 2/3. Is that correct?
Uh-huh.
That is why that a square is coming out. So this is the a square that's coming out. See that?
Yeah.
And the 2/3 is actually cube root of a squared.
Mm-hmm.
You can do that if you want, or you can do this after you get really comfortable with this, not right away. For the next couple of days homework, I want you to expand like this, and after doing maybe like around like a 10 to 15 problems, you get more confident, and then you can go with this shorter way of doing this. So by then you clearly get an idea about like how you split all these. Okay, so now do you guys have any questions so far from 9.1?
Nope.
Now don't be lazy to do the prime factorization. You do this until you get a really good idea about all these simplification.
It's not Honda.
Uh-huh.
I have a question. That's not really related to 9.1. What about did they say like what's gonna happen with the third benchmark?
No, I don't think it will be there. So
Oh, okay.
yeah, I don't think it will happen. So there is no third quarter benchmark and there is no fourth quarter benchmark. So if you're talking about your placement for next year, then I think it's the first semester grade and the 2 benchmark.
Okay.
Of course, if you're failing this semester, then they won't put you there. You get my point, right?
Yeah.
Okay. Yeah. So any 9.1 questions? If not, any other questions?
Nope.
Okay, so all right, then I think that's all I'm doing for today. I want you guys to really get comfortable with this. Just this prime factorization, simplifying of right. Okay?
Okay.
All right, I'll see you guys Friday around 11:45, between 11:45 and 11:50, okay?
Okay. Bye.
All right, take care.
You too.
Bye, thank you.
Bye.
Bye.